Hello to everyone listening, it's Tia Campbell here, and I want to thank you for tuning into my podcast, Psychology with Tia. Let's get straight into today's episode on emotion and time perception. I want to start off today by asking you to remember the most fun party you've ever attended, or the most exciting day you've ever experienced. Was there a point at that event where you looked at the time and thought, "Oh my goodness, how is it already time to leave? It feels like I only just got here." Now, I want you to imagine the most boring date you've ever been on, or the driest lecture you've ever listened to. Was there a point at which you looked at the time and thought, "Ugh, how have I only been here for 15 minutes when it feels like a whole hour?" Isn't it interesting how our emotions can alter our perception of time? The ability to accurately perceive time is critical for navigating through our daily lives. As an example, we utilize timing processes to gauge whether we have enough time to cross the road before an approaching car arrives. In addition to keeping us safe, an accurate perception of time allows us to maintain regular conversation flow with others, make it to events on time, and even assists us in daily decision making. Everyday decisions we make are based both on the anticipated duration and the experienced passage of time, such as waiting for the elevator or taking the stairs instead, or knowing if you have enough time to get a coffee from your favourite cafe before work begins. Our sense of time is said to be a function of the intricate interplay between specific cognitive functions and our momentary emotions. However, despite centuries of intrigue about how humans experience the progression of time, the exact neural basis is still unknown. There are many diverse models of time perception, with all of them slightly differing on how and where in the brain time is processed. In today's episode, I'm going to explain the two most popular models for the mechanism of time perception, and will then discuss some of the recent empirical work in the field. As with every episode, there will be a reading list provided with all of the research I've mentioned, so if you are interested, I would really encourage you to dive into the rabbit hole and immerse yourself in the literature on emotion and time perception. Historically, studies in this realm have frequently interpreted their findings within the context of the pacemaker accumulator, or PA, models of time perception. PA models postulate that there are three main levels in making a temporally based judgment, with temporal meaning relating to time, which involve clock, memory, and decision-making stages. During the clock stage, it is said that a pacemaker emits pulses at a given rate that are subsequently collected by an accumulator. The number of pulses collected by an accumulator represents the duration of time that has elapsed during the timing of a particular interval or event. Now, there is a switch that controls the transfer of pulses from the pacemaker to the accumulator. At the onset of the event to be timed, the switch closes. This allows the pulses generated by the pacemaker to enter the accumulator. Once the event is over, the switch opens and stops the pulse transfer. Therefore, the longer the duration of the stimulus, the more pulses that are accumulated, and the longer the duration is judged to be. In the next stage, which is the memory stage of the PA model, the duration of the interval being timed, which is represented by the number of pulses that have been collected in the accumulator, is transferred from working memory to long-term memory. It is then in the decision-making stage, the final stage, that the temporal interval being timed is compared to duration representations that are stored in the long-term memory. And this is done to determine if the current interval is of equivalent duration. Early studies in the field suggested that emotionally arousing experiences led to the overestimation of time. That is, participants believed that more time had passed during an emotional event than what actually had. In one study by Langer and colleagues in 1961, participants were asked to estimate an interval of time whilst moving towards a precipice and then while moving away from it towards safety. Participants overestimated how much time had passed when they were in fear and moving toward danger. Whilst the PA model has been highly influential in the field of interval timing, It is becoming increasingly apparent that these accounts lack sufficient neurological specification to isolate interval timing processes from other cognitive functions, including attention, memory, and decision making. It is because of this that the PA model has received criticisms around its biological plausibility. What's further is that despite fairly consistent findings in past research, such as the study I mentioned by Langer and colleagues, many studies suffered from methodological limitations. One major limitation that lots of research fell victim to was that non-emotional control conditions were not performed. What happened was that a participant's temporal estimate was compared with the physical duration of time rather than to estimates of a neutral stimulus. In more recent times, though, researchers are utilizing standardized tasks that allow for comparisons across multiple durations and emotional stimuli. Examples of these standardized stimuli sets are the International Affective Digital Sounds System and the International Affective Picture System. It was because of the limitations in both the research and in the PA model theory itself that researchers started coming up with ways to complement the model and further explain the cognitive process of time perception. The striatal beat frequency model, or SBF model, has been applied to several properties of interval timing, including the effects of arousal and emotion on clock speed. This upcoming explanation of the SBF model is a bit technical, so I definitely suggest doing some further reading if you'd like to increase your understanding. And if you are more of a visual learner, there is an excellent figure explaining the SBF model in the journal article How Emotions Color Our Perception of Time by Droit-Volet and Meck, and I've put the details of this paper in the reading list. In the SBF model, oscillatory activity of a specific subset of cortical neurons is synchronized with the on and offset of stimuli. When the stimulus is being timed, spiny neurons in the striatum detect specific patterns of oscillatory input from the cortex. It is by doing this that the striatum can read the temporal code given by the oscillating neurons in the cortex. The synaptic connections are then either strengthened or weakened depending on feedback and resulting dopaminergic input from the substantia nigra. Clock speed is altered in this system by the dopaminergic modulation of the cortical oscillation frequencies that are being input to the striatum. The dopaminergic inputs to the circuit proposed in the model are thought to be substrates of emotional distortions of time perception. There is limited research that actually interprets findings using the SBF model, and this is because it's still a fairly new model, meaning that there are still related concepts within that have not yet been experimentally verified, such as that the integration and storage of various time intervals occur through the weighting of cortical striatal synapses. Additionally, the SBF model is largely based on research with non-human animals and also does not yet point to specific regions of the human cortex that may support interval timing in the seconds to minutes range. So, despite there being limitations with both popular models and contention between researchers about which model best explains time perception, researchers are continuing their quest to fine-tune our understanding of it. They are building on earlier research in the field to discover how emotion states can influence our perception of time, and specifically through changes in arousal and attention. Internal clock models of interval timing suggest that changes in attention and arousal have unique influences on temporal judgments and also contribute to emotional distortions of time perception. When emotional events capture attention, processing resources can be diverted away from the timer. This results in the subjective experience of time to be shorter than it really is. In other words, time flies. This effect is said to be explained by a loss of pacemaker pulses due to the effects of attention on the switch. The redirection of attention away from the timer can increase the latency of switch closure. Additionally, inattention can cause the switch to fluctuate between being closed and open. Such effects have been observed in experiments that have manipulated emotion and attention via emotional pictures, faces, and conditioned stimuli. In 2011, Louis Pennet and Shermer set out to investigate whether pacemaker rate or attention represents a more viable mechanism for emotional effects on timing. Across 5 experiments, they found that participants perceived a timing stimulus as shorter when it was preceded by an emotional as compared to a neutral distractor. This was observed for both positively and negatively valenced emotional distractors and for varying intervals between the distractor and the timing stimulus. These findings support the theory that when people direct greater attention to the encoding of emotional stimuli, they tend to miss the onset of the timing stimulus, and time is judged to have moved by more quickly than it actually has. Another experiment by Gill and Droit-Volet in 2011 investigated time perception in response to ashamed faces in children and adults. Participants were shown images of faces expressing different emotions and were asked to estimate the temporal duration of their presentation. From the age of 8 years, the participants who recognized the facial expressions of shame underestimated their presentation time compared to the neutral faces. The authors interpreted these findings within the context of the PA model and thus suggested that the perception of a self-conscious emotion, such as shame, directs attention away from time processing, which produces a temporal underestimation. The subjective experience of time is lengthened, however, that is, durations seem longer than normal, by increases in arousal. Arousal is conceptualized in this field as any manipulation that modifies the rate of the pacemaker. According to the internal clock models, increased arousal accelerates the pacemaker, thus causing more pulses to accumulate. One study by Gill and Droit-Volet in 2012 set out to examine the effect of arousal on time perception when different emotions were considered. The participants were asked to estimate the duration of emotional pictures from the International Affective Picture System. The pictures varied either in arousal level for the same discrete emotion or in the depicted emotion. They found that time perception was perceived to be longer when viewing the emotion pictures compared to the neutral ones. The magnitude of this effect increased with arousal level. For example, the duration of disgust-inducing pictures, such as body mutilation, was judged as being longer than that of fear-inducing pictures, such as a snake. This suggests that arousal is a fundamental mechanism that mediates the effect of emotion on time perception. Further to this, a 2015 study tested the effects of emotion on time perception by assigning participants to one of 4 conditions. They tested a wide range of durations and highly arousing stimuli in the form of an electric shock. The participants' self-report questionnaire responses and skin conductance responses were assessed to measure emotional reactivity. The researchers found that stimulus durations were judged to be longer in the trials with an electric shock than in those without one, thereby meaning that temporal durations with high arousal emotional stimuli were judged to be longer. Additionally, they found that the emotion of fear speeds up the internal clock, thereby leading to an overestimation of time. In other words, fear made time drag on. This is consistent with historical studies, such as the one I mentioned earlier from the 1960s, where participants moving toward a precipice overestimated time. However, a recent study done in 2020 examined the effect of anxiety and fear on time perception and found slightly different results. The researchers combined a robust anxiety manipulation with a timing task in which the participants judged whether the duration of a stimulus was long or short. The participants significantly underestimated time in the induced anxiety condition, but the researchers were unable to replicate previous findings that fear leads to time overestimation. In other words, anxiety made time seem quicker, whereas fear did not seem to slow time down as findings have previously suggested. Despite this, the hypothesis that the passage of time slows down during highly arousing emotions, such as fear, has been supported by studies using fear-provoking pictures, looming stimuli, unpleasant noises, and electrical shocks. These findings are said to be explained by the theory that the perception of a threat automatically speeds up the internal clock. Observation of aversive stimuli also automatically activates a variety of physiological responses associated with the emotion of fear, such as increased heart rate, dilated pupils, and contracted muscles, so that the whole body is prepared to act for its survival in order to avoid imminent danger. In summary, I do want to point out that emotion, conceptualized here by arousal and attention, can be described in terms of positive and negative valence, or goodness and badness. Whilst there is a lack of research within the time perception field that investigates positively valenced emotions, it has been suggested that increased arousal of any emotional valence slows time down, and increased attention toward any emotional stimuli, positive or negative, will speed time up. Investigations of emotional influences on time perception have made considerable progress in recent times. We now also know that modulatory factors in time perception include gender, age, perceived control over emotions, and trait fearfulness and anxiety, meaning that future studies in the realm can attempt to control for such effects. Research in this area has also begun translating into the clinical domain, which may have really important consequences for understanding the perceptual experiences of individuals with emotion and mood-related disorders. Research into the neural basis of time perception is still in its infancy, but further consideration of neural mechanisms holds great promise for furthering our understanding of temporal distortions. So for any scientists or scientists-to-be out there, we need your help if we are to progress our knowledge in this very important area. Thank you so much for your time today, pun absolutely intended, and I'm trusting that this episode whizzed by in the blink of an eye. I can't wait to talk with you again very soon. This was Tia Campbell on Psychology with Tia. Bye for now.